Hi, hello. Welcome back to VSM Math tutorial, dear students. Those who are watching my channel first time, if you are not subscribed, kindly subscribe my channel and kindly put bell button for new videos. If I upload, definitely will get the notification. Okay, so let me start today's session or today's topic. The last few lectures I have covered Fourier series of the function with respect to the period c to c plus 2l, that is arbitrary period. Now in this class we are going to deal with half range Fourier series. Half range Fourier series. What is half range Fourier series? See what happens when we apply Fourier series definition for any periodic function. We have one complete series solution which contains sine and cos. But in some of the engineering applications or in some of the practical applications, we may need Fourier series only in terms of sine or Fourier series only in terms of cos. In that case, we may not need the entire Fourier series. So, how to find out that half of the Fourier series? So, that is nothing but half range Fourier series. In normal Fourier series, we are writing the range or limit as minus L to plus L or 0 to 2L. Okay. When it comes to half range Fourier series, the standard limit is 0 to L. The standard limit is 0 to L. So, half range Fourier series contains two types. One is Fourier cosine half range series, another one is Fourier sine half range series. Means we are finding half of the Fourier series. And what is the formula, sir? How the series looks like? So, I will write first, then I will move on to the problems. So, first half range cosine series is given by f of x equal to a naught by 2 summation n equal to 1 to infinity a n cos n pi x by l. So this is half range cosine series which contains constant and one coefficient a n. Here what is a naught? A naught is nothing but 2 by l integral 0 to l f of x dx. What is a n? A n is nothing but 2 by l integral 0 to l f of x cos n pi x by l into dx. So this is called half range cosine Fourier series. Sir, how we have derived this in the normal Fourier series we are writing 1 by l and c to c plus 2l. But here we are writing 2 by l. Why, sir? Because here we have operated even odd concept function to derive this formula. So in the integration we have standard formula minus a to plus a f of x dx, that is equal to 2 into integral 0 to a f of x dx when the function is even. Another formula is what? Integral 0 to 2a f of x dx. It is nothing but 2 into integral 0 to a f of x dx when the function is even. So we are applying this formula for these concepts. Then we have derived these formulae a naught and a n. So this is half range cosine series. Similarly, if I write half range sine series which contains only sine term. Okay, so that is summation n equal to 1 to infinity bn sine n pi x by l. What is bn? Bn is nothing but it is 2 by l integral 0 to l f of x sine n pi x by l into dx. This is the formula for bn. This is half range sine series. This is half range cosine series. Okay, please remember, dear students. So why half range series is preferred? because in some of the applications of engineering, we may not need the entire Fourier series. We may need only half of the Fourier series. That means I may need only sine series or only cos series. So to find out purely sine series and purely cos series, we are using the concept called half range Fourier series. Okay, I hope it is understood. So very simple. Rest of the procedure is as usual. We'll solve some 1 or 2 problems based on this half range Fourier series concept. Okay. I'll just take one simple problem. First problem statement says expand f of x equal to 2x minus 1 as a cosine half range Fourier series in 0 to 1. So this is a problem with respect to half range Fourier series. In the question it is clearly mentioned that they are asking us to find out cosine series. Okay, half range cosine series. So first we have to write the design of required half range cosine series, how it looks like. The required half range cosine series is f of x equal to a naught by 2 summation n equal to 1 to infinity a n cos n pi x by L. Now, as I told in the half range Fourier series, the standard limit is of the form what? 0 to L. So in place of L, what we have? 1. So that means clearly L equal to 1. So this is how we have to find out the limit. Now we have to find out this Fourier coefficient A naught. What is A naught formula? It is 2 by L integral 0 to L f of x dx. That is equal to, what is L value? We know it is 2 by 1 integral 0 to 1. What is f of x? F of x is what? It is 2x minus 1 into dx. Now, so it is 2 by 1 is 2 only. Integral of 2 constant, x integration is what? X squared by 2. So 2 as it is, x integration is x squared by 2 minus 1. 1 with respect to x is x. That is integration of 1 with respect to x is x between the limit 0 to 1. Here 2 and 2 cancel. 2 into upper limit is x square, first function is x square, second function is x. So between the limit 0 to 1. So what happens if I operate limit 2 into upper limit for the entire function 1 square is 1 minus 1 because x value is 1 square is 1 minus 1 is 0. Upper limit is 0 minus lower limit x is 0 minus 0. 0 minus 0 is again 0. Therefore it is also 0. So 2 into 0 is 0. So a naught by 2 is nothing but 0. Means a naught is 0. Therefore a naught by 2 is also 0. This is how we have to find out a naught value. Next we have to find out an. What is an formula? So it is 2 by L integral 0 to L f of x cos n pi x by L into dx. So that is nothing but we know L value is 1, 0 to 1. What is our f of x? F of x is 2x minus 1. So f of x value 2x minus 1 into L value is 1. Therefore it is only cos n pi x into dx. See, whenever the limits will be given other than trigonometric terms like pi minus pi, so these limits are arbitrary limits. Okay, 0 to 1, 0 to 3, minus 3 to plus 3, they are all called arbitrary limits. So now an equal to 2. Here we have to operate integration by parts method because we have two functions of x here. This will be u, this will be v. In the last class I have explained what is parts method, everything. Kindly those who missed that, refer my previous videos. Okay. So u. So first 2x minus 1. See, if you want, I write here integration of u into v dx equal to u integral v dx minus u dash double integral v dx dx plus or minus etc. So it will goes till our requirement. Okay. Now, so 2x minus 1 u into integral of cos n pi x dx minus u dash means differentiation of 2x minus 1. 2x differentiation is what? 2. 1 differentiation will be 0. Double integration of cos n pi x into dx. Then next term will be its differentiation. 2 differentiation will be 0. 0 into something 0. So between the limit 0 to 1. No need to write that term because the next term is 0. Now an equal to 2 into 2x minus 1 as it is. Integral of cos is plus sine. So it becomes sine n pi x divided by what is coefficient of x? It is n pi. Minus 2 into double integration of cos is there. One time integration I have here. This I have to integrate one more time. Sine integration is minus cos. Minus and this minus become plus. So it becomes cos n pi x divided by, already one n pi is there. We'll have one more n pi. So it becomes n square pi square with the limit 0 to 1. Now we know the standard result. What is the standard result? Sin n pi is 0 and sin 0 is 0. If we know that, no need to simplify this first term because what happens? If I operate upper limit, x value as 1, so it becomes sin n pi. Sin n pi is 0. 0 into whole term 0. Lower limit, if I replace x by 0, it becomes sin 0. Sin 0 is what? 0. 0 into whole term becomes 0. So the first term is directly becomes 0 after applying the limits. So we have what? N equal to 2 and this 2, it becomes 4. N square pi square. Remaining term is cos n pi x between the limit 0 to 1. So if I simplify it further, it is 4 divided by n square pi square. Upper limit is what? X value 1. So it becomes cos n pi minus lower limit x value is 0. It becomes cos 0. Therefore, an value is 4 by n square pi square cos n pi is minus 1 over n minus cos 0 is 1. This is our an value. So it is very simple. I hope you can easily solve this, dear students. If you refer previous videos, definitely you can easily understand how to integrate, how to apply the limits, everything. Okay, so we got a naught value, we got a n value. Therefore, we have to rewrite this given half range cosine series. Okay, therefore, the required half range cosine series. This is what our required half range cosine series we have. We have to substitute a naught and a n. So f of x, that is nothing but what? 2x minus 1. So its half range cosine series is what? A naught value we got 0. 0 into anything is 0. Summation n equal to 1 to infinity a n. So a n is what? 4 divided by n square pi square minus 1 over n minus 1 into cos n pi x. By L value is 1. So this is our the required Fourier series for the given problem. I hope you can easily solve this. Very simple concept. Okay, it needs only basic knowledge of integration. So this is all about Fourier cosine series problem. You can easily practice this. Then I'll move on to one more problem in this session. We'll solve one more problem with respect to half range Fourier series. Those who missed the previous classes, kindly refer my previous videos so you can easily understand the basics of Fourier series and the basics of integration. Somehow I have explained with respect to basics of integration. Those who are watching first time this video, kindly subscribe my channel VSM Math Tutorial and kindly like if you really like this video, and press bell button also for new notifications. I'll move on to one more problem with respect to Fourier half-range series. So one important problem I'll take. It looks like difficult, but it's not very difficult. Show that the sine half-range show that the sine half-range series for the function sine half-range series for the function f of x equal to Lx minus x square in the interval 0 to L is 8 L square by pi cube summation n equal to 0 to infinity 1 by 2n plus 1 whole cube into sine 2n plus 1 by L into pi x. So it looks like difficult, but it's very simple. If we know the proper method, basic method, how to proceed with the problem, then we can easily solve any type of the problems. Okay. Now the question is clear. They are asking us to find out half-range sine series. Okay. Solution. First we have to write the required half-range sine series. So what is half-range sine series? F of x equal to summation n equal to 0 to 1 to infinity, n equal to 1 to infinity. I think this is 1 to infinity, not 0 to infinity. N equal to 1 to infinity, Vn sine n pi x by L. This is our required half-range sine series. Call this equation as some star. Now, in the problem they have given limits varying from 0 to L. That means arbitrary limit. L is replaced by L itself. We are not supposed to replace L by pi or L by 2 pi anything. So limit is itself L. So don't replace L by anything. So L will be written as it is. And so in some textbook this Lx minus x square, they make you like this also. X into L minus x. Both are same. X into L minus x, if they give like this, you have to write like this and go ahead. Now we have to find out Bn now. So Bn, what is the formula? Bn is 2 pi L integral 0 to L f of x sine n pi x by L into dx. That is equal to, it is 2 pi L integral 0 to L f of x. What is our f of x? They have given Lx minus x square into sine n pi x by L into dx. Now we have to operate integration by parts method for these two functions. This is u and this is v. Now Bn equal to 2 by L, I'll keep it outside. First function Lx minus x square as it is, integral of what? Sine n pi x by L into dx minus, it's a differentiation. Lx differentiation is what? L minus x square differentiation is what? 2x. Double integration of second function, that is sine n pi x by L into dx minus over, then 100 plus, and x differentiation. L differentiation will be 0, minus 2x differentiation will be minus 2, triple integral of sine n pi x by L into dx into dx into dx, then 2 differentiation 0, not need to integrate further. And one common mistake the students will do, see we are differentiating only this part, don't consider this minus. This minus is formula minus. Okay, if you consider this, and you will get wrong answer. You may not get the desired required series what they are asking. Okay, so this minus is formula minus. While you are differentiating, this you are differentiating here. Only this part you are differentiating here. Okay, don't include minus. Now, where to simplify further? Bn equal to 2 by L. Lx minus x square as it is, Lx minus x square as it is. Integral of sine is what? Minus cos. Integral of sine is what? Minus cos n pi x by L divided by coefficient of x is what? N pi by L. Okay. Next, minus L minus 2x as it is, double integral of sine. See, one time integral I have here. This I have to integrate one more time. Cos integration is plus sine, but we have minus here. Minus into minus, plus. Okay. So what happens? It becomes sine n pi x by L divided by n pi by L whole square, because already one n pi by L is there, so we have one more n pi by L because we have integrated twice. Plus into minus minus, 0 minus 2 is what? Minus 2. Remember, it is triple integration. Here also please be careful about sign. Triple integration. One time integration sign is what? Minus cos. This I have, if I integrate one more time, what I have? Minus sign. Okay. Since we have minus, minus and minus, I made it as plus. But while taking the triple integration, you have minus here. Minus sin n by x by L divided by this. And if I integrate this one more time, sin become minus cos, minus and this minus become plus. So this minus will not change. Okay. So that is cos n pi x by L divided by n pi by L whole cube between the limit 0 to L. Between the limit 0 to L. So this is how you have to simplify. It takes some time, it needs patience. Please be careful while operating with signs as well as limits. If we do one small mistake, the entire answer will be wrong. Now, wherever it is possible, by simply looking at the term, we can make it as 0. We can. Now, you can see upper limit is L. X is what? L. L into L what? L square. This is again x value is L. So L square minus L square 0. 0 into whole term 0. Lower limit is what? 0. X value 0. 0 minus 0. Again one more 0. 0 into something 0. So for both upper and lower limit, this term is going to be 0. When it comes here, you look at the sign term. L value is what? X value is L. L and this L will cancel. Sin n pi. Sin n pi is what? 0. When you take this term, x value is 0, we have sin n pi. Sin n pi is, sin 0. Sin 0 is again 0. So for both upper and lower limits, this is also going to be 0. So we are left with only the cos term. So Bn equal to what? 2 and that minus 2. It becomes minus 4 divided by L. So I bring this denominator down to numerator. So what happens, that is L cube divided by N cube pi cube. L cube divided by N cube pi cube. We left with what? Cos n pi x by L between the limits 0 to L. Now what happens with this? 1L cancel. Bn equal to minus 4L square divided by N cube by cube. Upper limit is what? L. So L and L cancel. We have only cos n pi. minus lower limit 0, so it is cos 0. So that is equal to minus 4l square divided by n cube pi cube. Cos n pi is what? Minus 1 power n. Cos 0 is minus 1. If I simplify that further, I take this minus outside. So minus into minus plus 4l square divided by n cube pi cube. So it becomes 1 minus 1 power n. So that is the last simplification. We cannot simplify it further. So that is our Bn value. So if I replace Bn in the equation star, that is our desired French sign sense. Okay. So what happens Bn now? I mean f of x now. F of x equal to summation n equal to 1 to infinity Bn. So what is Bn? Bn is nothing but 4l square divided by n cube pi cube 1 minus 1 power n into sin n pi x pi n. So this is our series. So from this we have to show this, or we have to deduce this result. You can compare that and this. Okay. So sin term I have, everything I have. Now we have to simplify it and I should get it. Now what I am supposed to do? So what happens this one? I'll consider only that term. Consider 1 minus 1 power n. What happens? If I take n as the even value 2, 4, 6, 8, 10, minus 1 even number is plus 1. 1 minus 1, 0. So it becomes 0 if n is even. If I take odd values 1, 3, 5, 7, 9, 11, it becomes minus 1. Minus into minus plus 1 plus 1, 2. So if n is odd, so the value of this term becomes 0 when n is even. The value of this term becomes 2 when n is odd. That means if I consider 2, 4, 6, 8, 10 like that, this term is going to be 0, 0 into whole term is going to be 0. So for even values of n, this is not possible. Only we have to consider odd values. So odd values, how can I write? Odd number is nothing but 2n plus 1, right? It indicates odd number. N cannot indicate odd number because n equal to 1 odd, n equal to 2 even. So 2n I cannot write, even number, that is 2n is even. So odd number, how can I express? Only possibility is 2n plus 1. You take any value for n, it becomes odd. Now, so f of x equal to this I write it as 2 because I am considering only odd series. For even value of n, the series is going to be 0. So for odd values it becomes 2. 2 into 2, this becomes 4 l square divided by pi cube. Because pi cube and these two are constant, I am taking outside the summation. Summation n equal to 1, 3, 5, etc. up to infinity. Odd series I am considering. So this term I have written outside. Okay. This is already 4. This becomes 4 into 2. It becomes 8. Because in the result we have to show 8. So it's 2 into 4, 8 l square by pi cube. What else remaining? N cube. N cube. Since I am considering odd number, how to express odd number? 2n plus 1. So n is replaced by 2n plus 1. So 2n plus 1 whole cube. And sin, here also n is there. N is replaced by what? 2n plus 1 by l into pi x. This is what they are asking us to show. Okay. So it is very simple, my dear students. You can easily do this. Okay, I hope you enjoyed this session and you can easily practice yourself in home. Okay, so if any doubts are there, please put me in the comment box. Also, one more time request: those who are watching first time, kindly subscribe my channel, and if you like the video, please press like button, also bell button for new videos notification. Okay, so thank you all. we can meet in the next session. What? Come.
Actually